Hello, Legacy Sabers, Marsh here. So today we're going to do the last lesson on synthetic or finding all of our zeros. So what are we going to be doing during this method? Well, here are your steps. First, we're going to get a hint to get started. So we're going to use our graphing calculator or Desmos to be able to find our x-intercepts. We're going to set division, find the quotient. Then we're going to factor the quotient if possible. Sometimes you're going to have to use solve by square root or quadratic formula. And then we're going to find and list all of our solutions. Now, why can we do this? Well, something called the fundamental theorem of algebra, which is pretty famous actually. What this is told you is the number of solutions of a polynomial is equal to its degree. AKA, if I have a cubic, so a third degree polynomial, I should have 3 solutions. Now, these solutions can be integers, fractions, square roots, double counted solutions, which means that you get 2 twice, or sometimes you can even have an imaginary solution. So keep that in mind. Sometimes that will happen. So let's use the fundamental theorem of algebra and find all of our factors and all of our zeros. So I have x cubed plus 5x squared plus 4x plus 20. Normally we would have created our possible rational zero list, but over here I do have a graph of this, and it looks like -5 is a definite zero. So let's go ahead and use that on my synthetic division. So I have 1, 5, 4, and 20. Let's choose my synthetic division here. 0, that's 4, -20, and that does work perfectly. Wonderful. Now let's go ahead and write out what my new polynomial is. Since it was an x cubed, it's now down to x squared, so 1x squared, no x, but plus 4. Looks like I need to solve that, so I'm going to set it equal to 0. Get the x squared alone, it looks like. So solve by taking a square root. So let's subtract 4. So we get x squared equals -4. Square root both sides. X equals, looks like I is going to come to the party, right? Because that I and the square root of 4, because I have that negative underneath there. So it looks like x can equal plus or minus 2i. So on my list here, I'm going to write my factors, kind of like what we did for our x factor activity. One factor would be x plus 5, because that would be what would make that x minus 5 as 0. And then my other factors, I have x plus 2i. That'd be the -2i, and then x minus 2i would be my positive version. And then the zeros are x equals -5, 2i, and a -2i. Those would be my factors and my zeros. Not a whole lot new today, just kind of using the same information that we've used before. Let's try the second example here. So I have 3x to the 4th plus x cubed minus 10 squared plus 2x plus 4. Bring up my graph here. It looks like -2 is a possible zero that would work. So let's try -2. I got 3, 1, -10, 2, and 4. Let's do my synthetic division here. That was upon -10, so that'd be 0. 2, -4. No remainder. Good. So this would be the polynomial of 3x cubed, because I started with the 4th, dropped to power, -5x squared, and then plus 2. So let's try factoring. 2 times 3, that is 6, and I need to get a -5. So that looks like it would be a -2 and a -3, right? That would give you a -5. So if I would expand my middle, because they're both going to be squared, right? And then I can factor out. So it looks like it's going to be a x squared there. So that'd be 3x minus 2. It looks like a negative is all for that. So that'd be 3x squared minus 2. Not the same. You know what? I bet these aren't factorable. So he is not factorable as he stands at this current time. Now, that's normally going to happen. If you start with an x to the fourth, usually you're going to want to have to do synthetic division. Not once, but twice. So, we are going to set up our second round of synthetic division. Now, this row right here is not going to be considered. It's just going to be these numbers. It looks like 1 is a good number, so let's use 1. I'm going to drop down 3. 3 times 1, it's going to be 3. Negative 2. Negative 2, negative 2. And I'm going to get a smiley. So this is now the equation 3x squared minus 2x minus 2. So I'll get negative 6. Numbers that make negative 6 but add together to give you negative 2. Not a single one. Well, I now need to solve this quadratic. How can I solve a quadratic? I can use the quadratic formula. That works. So I know it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So my b is negative 2, so it'd be opposite of my b, so that'd be a positive 2. Negative 2 squared, that is 4, minus 4 times my a, which is 3, times c, which is negative 2, all over 2 times 3. So I'll get 2 plus or minus, what have I got underneath here? Negative 4 times 3, that's negative 12, times a negative 2, that is positive 24, positive 24, yeah. So then 4 plus 24, that's 28 over 6. 28 breaks down into square root of 7 and square root of 4. Square root of 4 is 2. So I am left with 2 plus or minus 2 square root of 6. So no, square root of 7. Whoopsies. Let's fix that. Over 6. This does simplify down into 1 plus or minus 1 square root of 7 all over 3. So, notice guys, I do have, since it's the fundamental theorem of algebra, I do have 4 answers. I have 1, 2, 3, and 4. So, my zeros would be negative 2, 1, and 1 plus or minus 1 square root of 7 all over 3. Yes, that's a really long answer. And my factors would be x plus 2, x minus 1, and then the factors that came out of, that came this would be technically this one right here, this quadratic, or you could write them with x minus and then the positive version of that as well. We'll talk a little bit about writing your factors and writing your zeros in class when you get back after watching this. But that's the end of this video. See you later, Sabers.